Hello. Today I'm going to talk a little about a project I was involved with at the Lycoming College Clean Water Institute examining urban stormwater systems in small municipalities. This work is part of a much larger project based on the rationale that small towns and municipalities may have limited capacity to address stormwater regulatory requirements. The overall goals of this project are 1. For the CWI to bring expertise, time, resources, collaboration, and infrastructure to local partners to help with meeting stormwater requirements. And 2. To develop frameworks for students, training through experiences in environmental education and curriculum development at Lycoming College. The central theme for this broad project is urban stormwater management, but we are taking a holistic approach that combines teaching and research. That central theme starts with urban stream ecology, and specifically how complex urban ecosystems can be. The urban stream syndrome is a well-known model that describes the complexity as is shown in this diagram. I'm not going to go over this diagram, obviously, but you can see how complex these relationships are among different components. But what is also clear is the link between urban development, impervious cover, and stormwater systems in the catchment with abiotic and biotic conditions in stream ecosystems. Like most environments in urban systems, conditions in urban streams are largely dependent on human activities. In natural streams, hydrology is the foundation that determines how other abiotic features determine what biota exists in streams. In urban streams, however, that hydrology is controlled by management actions related to urban development, channel modifications, stormwater systems, stream restoration, etc. Thus, the human component of management is seen as the foundation for both biotic and abiotic conditions in urban streams. Management, however, is not a common component of college coursework and student training in the natural sciences, such as ecology. In 2009, Seth Wegner and others published this paper, 26 Key Research Questions in Urban Stream Ecology. You don't have to read this slide, but what we've done is pull some key unanswered questions out of the list and highlight the key words. If we organize these topics, you can see that what is needed in urban stream research, and is still relevant now, is a mix of questions related to basic and applied ecology of urban streams. But included in that list were several aspects related to management and a specific statement about needing to improve communication. Thus, we believe that teaching and training in management, communication, and the interactions among those two are important for creating a foundation for Lycoming College to help support local municipalities while teaching students about urban systems. So, an important component of this project is teaching students to apply and communicate urban stormwater science. As you can see, this conceptual diagram, the science of urban streams, is at a foundation of what we are doing. This includes an understanding of research examining ecological, social, and pedagogological aspects of urban streams, management, and education. From this, we are creating a teaching and training program through new components of Lycoming's curriculum in environmental science. This is important since we've discovered that a lot of training for managers in local governments who aren't necessarily scientists occurs on an ad hoc basis on the job. In other words, they sort of just have to figure out as they go. Direct training can prepare students for these types of positions. The curriculum we are developing focuses on two aspects. First, the foundation concept of how to apply basic science to management and restoration. Second, on how to effectively communicate these topics through environmental education, extension, and research communications. The interdisciplinary nature of the knowledge needed for this training makes the liberal arts approach ideal for this type of curriculum. Specifically, the goal is for students to learn skills for science communication, what it is like to work as a manager at a local government level, how to perform interdisciplinary research, and how to create and deliver effective environmental education. As Dr. Bob Smith puts it sometimes, we want students to learn people-facing responsibilities. At Lycoming College, my mentor, Dr. Bob Smith, is working with colleagues there to help expand the college curriculum to address these issues. As with all teaching, in the sciences at Lycoming, the student experience is focused on experiential learning through hands-on field, lab, and GIS learning. Specifically, Dr. Bob is teaching an urban ecology course designed to cut across natural and social science disciplines. A lot of training for students, however, is accomplished outside the classroom through working with the CWI. Some of the types of things being taught to students include the realities of local politics, management, and dealing with stakeholder concerns, understanding how limited revenue affects project options and what sources of revenue are available, knowing the social science that drives local community perceptions of management issues such as stormwater, but also learning the integrating local communities is key for success. Learning how to manage interpersonal interactions, for example, the importance of building trust with partners. To accomplish this, students attend stakeholder meetings and meetings with local government to see firsthand how this aspect of science works. We believe these are typical components of an undergraduate science class. What I want to do now is tell you a bit about my experience working with the CWI as a sort of case study that demonstrates how the student's experience is being shaped for this type of training. I have worked extensively with the CWI's environmental education work. This work is directed by my co-author and the director of CWI, Dr. Mel Zimmerman, who has a passion for developing stewardship of local streams and rivers. I worked on programming for the Rose Valley Fishing Derby, River of the Year events for the Loyalsock, and the Hiawatha Floating Classroom. The most experience I have, however, is working at the Waterdale Environmental Education Center. Last year, at the RiverMeeting, I presented on best practices for implementing an environmental education curriculum that Dr. Zimmerman created in collaboration with faculty and students in the education department at Lycoming College. Really quickly, what I found that this curriculum was most effective delivered when we used outdoor classroom. Obviously, getting the students outside to experience the environment did the best job of capturing the attention of these K through 12 students. We used inquiry-based learning when possible, where students learned as they worked through questions about the environment, even if done over a short time frame. A hands-on approach was always the best way to get students engaged. And using live specimens was also a great teaching tool that kept students engaged, but also specifically helped me and the other students teach students about natural history and diversity. Dr. Bob especially liked having me around because he's sort of afraid of snakes, and I very much am not. Lastly, we feel that having specific learning outcomes to address helps us focus our delivery and refine approaches. So be sure, like any teaching, that the intended learning outcomes are clearly identified and evaluated. Due to the COVID-19 pandemic, the CWI had to pivot its focus for the grant a bit to have a greater emphasis on extension and developing materials to managers in the community virtually. The Penn State Extension website describes extension as an activity where scientists deliver science-based information to people, businesses, and communities to help them address problems and take advantage of opportunities for improvement and innovation. As such, the CWI is in the process of developing extension resources in urban stormwater for local municipalities. The pandemic has slowed progress, but the goal is to create an extension website and populate it with materials directed to diverse audiences. For example, students in the urban ecology course I mentioned earlier are creating content for the website as part of the class. After the pandemic ruined my research on invasive plants last spring, I started working on this component of the project. I've worked with the faculty and staff in the CWI to create background information about urban stormwater and urban streams in general for the website. I wrote extension articles. I have a lot of training in art and design from my coursework at Lycoming and was able to help create this logo for the project. Most recently, I started research designed to answer specific questions about ecology of urban streams. As I said, one of the things I did over the summer was write extension articles. A typical goal of writing extension articles is to summarize recent scientific research so that a non-science target audience can understand it and use the knowledge in their lives or businesses. As a learning experience, students get to practice science writing and must develop an understanding of the science. Often, students are taught to write for a science audience in science classes, so this can be a different experience. For example, I summarized this article by Zhang and others from 2015. It examined aspects of green roofs and found specifically that the amount of rain, depths of soil, and type of soil materials can affect runoff from green roofs. In addition to summarizing the technical aspects, the main message of my extension article were that green roofs can be good when they are sinks for pollution, but green roofs can also be sources of pollutants through runoff if not designed correctly. Green roofs are often just added to the list of good options for stormwater control, but like most things, there can be trade-offs. What I want to quickly do with the last few minutes of my talk is provide a very coarse overview of my undergraduate research related to the CWI Stormwater Project. This is applied research and is directed towards answering a specific question that can help develop effective management approaches. In this case, we are collaborating in an informal capacity with the PADEP to help find ways to better assess the outcomes of restoration projects done as part of watershed implementation plans to use stream macroinvertebrates as bioindicators. What I am going to present is some very preliminary results examining how stream macroinvertebrates richness changes along environmental gradients. Because we are interested in how richness changes geographically, we are also examining how richness changes with latitude and longitude. As I said, this is a very coarse overview. I'd be happy to discuss this research in more detail after the conference if anyone is interested. Our methods in general uses the statewide biomonitoring dataset available on the PADEP's website. This has over 7,000 data points, 64 variables, and the taxonomic data for samples. The sample sites are shown in orange on the map on the right from the website. We filtered the data to analyze a single sampling approach, which was the standard DNet samples with a 200 specimen fixed count subsamples. We examined the distribution of richness and other variables, but I'm only going to talk about richness in this talk. Lastly, we used the model selection procedure to evaluate how our predictors are related to the response variables. As stated, we looked at several response variables, but are only going to show taxa richness in this example. We looked at the relationship of richness with total watershed area, thinking that larger streams may have more species, total urban cover, since urbanization is expected to decrease richness, habitat score, since poor habitats should have fewer taxa, and latitude and longitude to start examining geographic gradients. We found that richness was normally distributed. We also found an expected relationship between richness and urban cover. Commonly, this triangle-shaped pattern emerges where low richness is observed at low levels of urban cover. In other words, the range of richness values is quite large at low levels of urban cover. Examining this pattern is one of the long-term goals for this study. With this model selection procedure, first realize that I'm skipping over a lot. Like I said, I'm happy to discuss this more later. But we compared models representing all possible combinations of the 5 predictor models, which was 32 models using a linear model framework as a first pass. We compared model fit using AICC, and the best model has the lowest AICC value. We found that the best models include latitude, longitude, urban cover, and habitat score as significant predictors of macroinvertebrate taxa richness. The adjusted R squared was 0.27, and the overall model was significant at an alpha of 0.05. Each predictor was also significant, and the coefficients showed that latitude changed with richness and is worth looking into more thoroughly. Comparing the predicted values from the model to the actual richness values, that the model does a decent job giving the large amount of data, but obviously we are going to continue examining the data. This research isn't finished, but a few other outcomes are evident. Like all colleges, generally the CWI uses research as a tool for training. I was able to get experience learning how to use our statistical programming for forming this research. It was also an ongoing research project that students can continue to use for training. Possibly most importantly, we'll be able to create a product that is useful for our collaborators. The secondary outcome related to communication is that I'm giving this overview talk rather than one of the professors. The goal of the project is to teach people-facing responsibilities and communication skills. This is ironic since I'm giving this talk through a YouTube movie, but I think you all get the point. In conclusion about the entire stormwater project, this is a multifaceted project, and two other students and Dr. Leslie Rick, our postdoc, all presented at the meeting. The interdisciplinary nature of urban stormwater management is a challenge, but also offers unique opportunities for training that is highly suitable to the liberal arts model of education. Lastly, the holistic model here is achieving several goals related to student training and communicating sciences to various audiences. I want to acknowledge the following, but especially want to acknowledge the support from the Arthur Vining Davis Foundation and our partners at the Williamsport Municipal Water Authority and Bill Burdett from Millisock Township. Thank you, and I'll take questions if there is time.